Geometro Ninjas. Today we're going to talk about inscribed angles. So an inscribed angle is where our vertex is now on the circle. So we talked about central angles last week, where our central angles were congruent to their intercepted arcs. But today we're talking about inscribed angles. Inscribed angles are not congruent to their arcs. An inscribed angle is actually half of its intercepted arc. When we are intercepting a diameter, it's going to form a right angle. And if you think about it, when we look at our diameter, okay, the diameter itself is 180 degrees. So from B to C is our semicircle, which would be 180. If we're following our inscribed angle rule, half of the inscribed angle, so 180 divided by 2, would give us a 90. So if we have an inscribed angle that has endpoints on the diameter, it is going to form a right angle. And our last type of arcs that we're going to see today are inscribed angles that are intercepting the same arc. They're intercepting the same arc. Our angles must be congruent. So you can kind of see ABD and ACD both intercept arc AD. So whatever this arc is, if it was 60 degrees, half of that, 60 divided by 2, would give me 30, no matter which arc we're talking about. Right? What's wrong? Talk to me. You can ask questions.
No, I didn't realize you're on that one.
Oh, I'm sorry. All right, so let's put our arcs in inscribed angles into action. So we look at our first one. So WXY is our angle in question. The vertex occurs on the circle. This is an inscribed angle. Our vertex is on the circle. So to find the measure of that angle, we're going to take a look at our intercepted arc, which is 62. So we're going 62 divided by 2. So our angle has to be 31 degrees. So if they're giving us the angle, we're going to divide it by 2. Or they're giving us the arc, excuse me, we're going to divide it by 2. Well, what happens if they turn it around on number 2, and now instead of giving us the arc, they want to start us off with that inscribed angle? Instead of dividing by 2, we're going to divide our arc by 2. So DGF is our arc in question. So to find it, we're just going to take the angle they give us and multiply by 2. So we get 226. What's up? Good? Right. Number 3. I do not have any numbers. However, we know that PR is a what? PR is a diameter. We know it's a diameter because it's a chord that passes through the center. Yes, you're going to see vocabulary on Friday. Yes, you're going to see vocabulary on your test. Test is in two weeks. Quiz. Because I'm evil. Okay, we got it. Geometro Ninjas. Yes. Okay. So we know that this arc is part of a diameter, so this arc has to be a semicircle. The measure of a semicircle is 180 degrees. So then our angle itself, 180 divided by 2, is 90. It is a right angle. That was our second rule we talked about. Angle Q, PQR. Number 5, they throw a little wrench at us. Okay? So they want us to find the degree of JKL, but they did not give us this arc out here to start, because JML is our inscribed arc. It's the one that's included. But they did give us the other two. So if we remember back to when we first started talking about circles, the full degree measure of a circle is 360. And we're going to subtract the two arcs that we know. The arcs that we know are 53 and 65. Bless you. So 360 minus 53 plus 65 is 242. And then 242 divided by 2 means that the measure of JKL is 121 degrees. Everybody good with that one? Yes. Number 6, we kind of get our first look at that intercepted arc. So we've got angle RST, and we have angle RUT. They are both intercepting arc RT. So by definition, if they're intercepting the same arc, these angles have to be congruent. Well, before we even get going, we've got to find out what RT is. And just like before, they kind of told us what the other things were around it, and we're going to have to do a little bit of work on our own. So we know the full circle is 360 degrees. And we're going to subtract the other three arcs that we know. So 64, 75, and 139. Okay, we're going to go ahead and subtract those. So arc, the measure of RT, is 82. Inscribed angles are exactly 1/2 the value of their intercepted arc. So to find RST and RUT, we're just going to divide our arc by 2. So 82 divided by 2, each angle is going to measure out and become 41 degrees. So that's the basic rules in action. Now let's go ahead and sprinkle some algebra 2, our algebra on top. Let's look at number 8. They want us to solve for x. They gave us angle LMN as 67 and arc LN as 4x plus 58. If it helps you, go ahead and outline what you're dealing with. You don't have to, but some people are more visual, and having that like compounded space, they can see what's supposed to happen is better. Before we continue, is MN a diameter? Why not? It's right next to the center. Okay, so if MN wanted to be a diameter, it has to pass through the center. So because it's a little off to the side, that's not going to work. If it's just a regular old chord, absolutely. Not a linear pair, what do you mean? If there was another angle coming off it, you could, but no. As this stands, there isn't one. Hey, so if we're setting this up, if we're solving for the inscribed angle, it would look something like this. The measure of angle LMN is equal to the arc LN divided by 2. So if we were setting this up algebraically, before we even get started, this is what we'd be looking for. Angle LMN is equal to arc LN divided by 2. So from here, we can substitute who we know is supposed to be there. So the measure of LMN is 67, and arc LN is 4x plus 58. Of course, divided by 2. So our goal here is to solve for x. So we've got to start isolating that variable. First step we need to do is, I know you guys love fractions so very much, but let's go ahead and clear that denominator. We're going to multiply both sides by 2. What that does, it knocks out the 2 on the right side, gives us 134 equals 4x plus 58. Now it just becomes a 2-step algebra problem. Subtract 58 from both sides. 134 minus 58 is 76. And then again, we're trying to isolate that variable, so we're going to divide both sides by ket. So x equals 19. Again, we kind of took some extra steps at the beginning. Some of us may like it, some of us may not. But if it helps us get organized, I'm all for it. Number 9. Solve for x. We don't know any of our arcs. We don't know any of them. It's almost like they don't want us to use those arcs. They want us to use a different rule. WY is a diameter. And since we've got an inscribed angle intercepting a diameter, it has to be a right angle. Inscribed angle intercepting a diameter has to be a right angle. Okay, and again, if I was setting this up so that we would know the measure of our angle, WXY, is equal to the arc, which is a semicircle, so YW, over 2. Okay, so we could set it up the original way we learned, or if we're using our rule, we could say that WXY is simply 90. So there's a couple of options to go about it. If you don't immediately recognize that that angle itself is 90, that's fine. You can still do it the other way. Okay, so we got 13x minus 1 equals 90. Add 1 to both sides. 13x equals 91. Divide both sides by 13. So we know x to be 7. Number 10, they're going to reach back into our geometric capabilities. They want us to find x. Yes, sir. Inscribed on the diameter. Yep. Yep. So number 10, they want us to solve for x. However, x is not on the angle they gave or the arc they provided with us. Okay. Yep, we're eventually going to get there with the triangle sum theorem. Now we could double x, find wy, subtract that from 360, and then use that to get w. But let's work a little smarter, not harder. Let's go ahead and solve for this angle XYW. Let's go ahead and solve for that one because we know it has an intercepted arc value. So measure of angle XYW is half the measure of arc XW. So angle XYW equals 78 divided by 2, making XYW 39 degrees. Okay, so we can substitute that right in there. And like your classmates noticed, well, XYW is simply a triangle, meaning we can do the triangle sum theorem to find that value. Just because we haven't used that in a little bit doesn't mean it's not still available to us. That's the cool thing about geometry. It kind of builds on itself and you can almost use everything as you go, especially triangle rules. They're going to be there forever. Okay, so 114 plus 39 plus 7x plus 6 is equal to 180. The inside of a triangle adds up to be 180. So we're going to combine like terms. 7x plus 159 equals 180. Subtract 159 from both sides. I'm going to move it on up here because I'm running out of room. So 7x equals 21. Divide both sides by 7. We find out that x equals 3. All right, let's do one more of these before we move on to our inscribed quadrilaterals. All right, 15. Angle ABD is 6x plus 26. So ABD. 6x plus 26. ACD is 13x minus 9. They want us to solve for the measure of arc AD. Okay. So these two angles intercept the same arc. So if they intercept the same arc, that means they have to be congruent. Let's talk about corresponding angles. So corresponding angles do exist here. One in, one out. However, we cannot use our corresponding relationship. How come? They are not parallel lines. If they were parallel, I like where your head's at, and we can probably work in that direction. However, these are not parallel, so we cannot use them. We're going to use our intercepted angles. So they're intercepting the same arc, so they have to be congruent. So because they're congruent, we're just going to set them equal to one another. 6x plus 26 equals 13x minus 9. Okay, our goal is to isolate our variables. We're going to subtract 6 from both sides. Because you guys are rock stars, I'm going to add 9 on the same step. Okay, going to knock out those. So 26 and 9 is 35. And 13 minus 6 is 7. Divide both sides by 7. So x equals 5. Okay, that's only half the battle. We have got to now find out. We're going to substitute it in to find our angle measure. Yes, sir. Yep. So we know ABD is equal to half the measure of arc AD. So we are going to double it because we have the angle. If we had the arc, that's when we half it. Okay. So I'm just going to substitute 6 times 5 plus 26. We substituted the value we found for x. 56 equals arc AD divided by 2. And then to get arc AD by itself, multiply both sides by 2, just to clear that denominator. So essentially all we did was multiply that angle by 2. So our answer is 112 degrees. Any other questions on that one? That's a good one. I like that one. Okay, that pushes us to our inscribed quadrilaterals. We talked about quadrilaterals 2 units ago, right before transformation. If a quadrilateral is inscribed into a circle, the cool part is opposite angles are supplementary. What does it mean to be supplementary? Their sum is 180. So we look at our circle to the right. Circle P has got ABCD quadrilateral inscribed in it. That means that the measure of angle A and its opposite, angle C, are 180. And then the other rule, angle B, and its opposite, angle D, are also 180. A and D are not necessarily congruent, but they could be, but not automatically. Correct. If it's like a rectangle or a square, yeah. Then we're talking about congruency. PDF. Okay. So number 1, angle J and angle K. Right. So we know J and its opposite L are equal to 180. And then K and its opposite M are equal to 180. We do know angle L. Angle L is 92. So to get L, or to get J, said J, wrote L, good job. We're just going to subtract 92 from both sides. And we find J to be 88. Same thing for the other sides. We know M is 45. So to find K, we're going to subtract 45, and we find out K is 135. Let's look at number 3 because it's fun. Sure. So number 3, we can find A, B, C, and D based solely on arc AB and arc BC. I know they threw a whole lot at us, but it's okay. What we're going to do first is we're going to find the measure of our inscribed angles. So we've got angle A here as one of our inscribed angles. And then because I don't want to find C, we can just flip it around and find D. So we kind of have 2 different arcs that we can solve for. D is probably the easiest one. How come? Yep. So the measure of angle ADC is equal to half of which arc? AC. So ADC, AC is 39 plus 61. And then 39 and 61 added together is 100. 100 divided by 2 lets this angle be 50. All right, we're 25% there. Now we're going to go ahead and find angle A, BAD. It's a bad mamma jamma. We can find B based on D, correct? That will be a supplementary relationship, but we still need to find A or C. We have to do one or the other. And I'm going to go with A because I don't want to have to find what the measure of this arc is. Because if I went with C, that's what I'd have to do first. Yeah, but you still have to find C.
Yes, you would just be supplementary.
Right. But you're doing extra work to get to C when A is already given to me. I already have angles for A. I don't have all the angles for C. Right? So I still have to do it one way or another. So BAD is congruent or is half of arc BCD. So why did I go 3 letters for that one? Greater than 180, which makes it a major arc. So that bad angle is 61 plus 147 divided by 2, which is 61 and 147, 208? No. Yeah, 208 divided by 2 is 104. So we know 8 is 104. To find the other 2, we know that opposite angles are supplementary. So to find C, we're saying 180 minus 104 makes it 76. And then we do the same thing for B. B is opposite D. So 180 minus what we found for D. So B has to be 130. That is a great math problem. One of my favorites. All right, let's do one algebra, then I'll set you free. Not to run away or anything, but which one you want? 5? 5 looks fun. Okay, so what do we know is true about B and T? They are supplementary because they are opposite angles on an inscribed circle or inscribed polygon. So we know the measure of SVU, the special victims unit, and the measure of STU. Is that right? Not SVU? Did I mess it up? Okay, so SVU and STU is 180. We know SVU, one more time? Because it's a polygon inscribed in a circle. So by definition, the opposite angles are supplementary. Good? So 133 plus 62 minus 5x equals 180. Combine like terms on the left. 133 plus 62 is 195. And I'm going to write that 5x first because that's how you're supposed to write it. Subtract 195 from both sides. Negative 5x equals negative 15. Divide both sides by negative 5. We know x is negative 3. So that's our inscribed angles lesson. Positive 3, thank you. Good catch. That's our inscribed angles lesson. You guys have a PDF for homework, and we'll see you next time.